Hey guys, so today we're going to learn a little bit more about area. Please have this sheet out that you see here in front of you that I handed you today. If you don't have it, I will try to upload it to Edmodo, see if I can find the hard copy, but please try to have it in front of you now. Okay, so the first thing it tells me is that I need to measure the length and the width of each square and rectangle below, and then calculate its area. As we know, area is length times width. And I have you all remember that by a Lil Wayne production, right? Okay. So, how many units is the width? 1, 2, 3, 4. So therefore, this is 4 units. And at the top, it's 4 units. Area equals length times width. So 4 times 4 is 16. So inside is 16. Okay. For this next one, it's going to be how many? 4. Good. And then 1, 2, 3, 4, 5, 6. So length times width. 4 times 6 is 24. So this will be 24. Now, it's not giving us feet or inches or centimeters. So what these are called are just units. And with area, our units are always squared because area is two-dimensional. So this is 16 units squared and this is 24 units squared. Okay? Here we have 1, 2, 3, 4 by 3. Area equals length times width. And so your area will be 4 times 3, which will give you 12 what? Units squared, because we're still finding the area. And then on this one, we have 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7. So area equals length times width, width, and that will give me 5 times 7, which is 35 units squared. Okay, so we've done that so far. Now, down here, it says, using a ruler, we're going to draw a diagonal from one corner to the opposite corner on shapes A, B, and C. Okay? So let's zoom this out a little bit. Okay. This is figure A, so we're going to draw a diagonal. I'm going to use red from this top corner down to the opposite corner. And if you want, if it's easier for you, you can use a straight edge. So I'm going to line up my corners. And there's one. So it should look like that. Here's, now it said the top edge. From one corner to the opposite corner. So could I start up here? Yeah. I could go this way. We just have to go to the opposite one. And that was figure A, this is figure B, and then we have figure C. So I'm just going to do it this way again. Okay. So now we've done step 1. Step 2, along the bottom edge, so down here, of shape D, mark a point that is not a vertex. Vertex also means corner. Using the ruler, draw a line from each bottom corner to the point you marked. Okay, so, I don't know. I'm just going to pick here because it's on a line and I like it. Now, it's not a corner. These are the vertexes. Each rectangle has 4 vertices. Vertices is plural for vertex. So, but it still told me I have to draw a line to the corner like on the previous one. So, here's my dot. Sorry, hope you can see. Okay, here's my dot. And I'm going to draw a line up to the corner. So there's one. And then here, I'm going to connect it to the other corner. Ooh, that was a little floppy. Sorry. Okay. Alright. So it says 3 triangles should be formed. And here we go. 1, 2, 3. And that was figure D. So we did number 2. Okay. Next it says we have to cut out the shapes. Okay. So I'm going to write my figures, what they are, in these little things so that when we cut them out, we still know what we're dealing with. Okay. So, get your scissors. And I'm going to pause this while you cut. I think. Okay, so now I have cut all of them out. Here I have figure A. Whoops, let me get it where you can see it. Here I have figure A, figure B, figure C, and figure D. Okay, on these instructions though, it tells us that they want us to cut out the shapes and then divide A, B, and C into 2 parts by cutting along the diagonal line, which is why I put a little A in both of them so I knew what it was. Alright, so here we're going to cut right here. That's A. Here we'll cut B. Here we'll cut C. And then it says for D, they want us to cut into 3 parts by cutting along the lines we drew. So here's going to be 1. And then this will be my second one. Okay? So again, here we have A, B, C, and D. Now, how do these result in the original shape? If I was to ask you, well, together it was 16 square units, figure A was. But if I was to ask you how much each one of these triangles would be, what would you say? What would you do? Well, I would approximate it. So, for instance, I would do that this figure is 1 square, this is 2, this is 3, this is 4, 5, 6 definite square units. And then this looks like a half, and that looks like a half. So a half and a half is a whole, so that makes 7, and then a half more, and a half more would be 8. So my answer for the triangle would be 8 units squared. Okay? Now, these 2 triangles are completely congruent. They're the exact same. If I was to put them on top of each other, you notice, whoops, if I can get it there, you notice they cover each other up. They're the same exact size. Therefore, this one must also be 8 units squared. Okay? If I add them together and turn them, I create a square, a rectangle. Well, actually a square, right? Because all the sides are even. And I get my original 16 units squared. Which tells me that the area of a triangle is half of what the area of a square was. So if our formula for a rectangle is area equals length times width, then a triangle's formula would have to be area equals the length times the width and then divided by 2, right? Let's see if that works over here. Here we had 24 units squared, right? And these are both the same kind of triangle. They're right triangles. Now let's see, we have 1, 2, 3, 4, 5, 6, 7, 8 definite squares, right? Okay, well, this one and this one seem to go together and make 9. This one and this one seem to go together to make 10. These two seem to connect together to make 11. And then this is about half, and this one goes together, and that would make 12. So together, for this triangle, I'd have 12 units squared. Again, it's area, so all our units are squared. Well, if this is 12 units squared, then this would have to be 12 units squared. If I put these back together in the rectangle, originally I had 24 units squared, and each triangle is 12, so it's half the original area, which is half length times width. So another way we could write the triangle formula for area is area equals 1/2 the base times the height, right? So now, we've already looked at these. If we look at C, and we know that these two together is 12 units squared, what do you think the area of each triangle would be? Did you come up with 6 units squared? If so, you're correct. And we can check that by seeing that we have right here and right here, that's 1 square, 2 squares, 3 squares, 4 squares. And then we have 5 squares here and 6 squares there. So good, perfect. Alright, then we have, last but not least, D. Okay, altogether it was 35 units squared, but now I have 3 triangles. Well, this is the formula we've come up with. And in here, we knew that the base was 3, and the height was 4, and 3 times 4 was 12, divided by 2 gave us 6, which is the area we came up with. Here, we knew that the triangle was 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. 4 by 6 is 24, divided by 2 gives me 12. And on A, we knew that this triangle was 1, 2, 3, 4 by 1, 2, 3, 4. 16 divided by 2 is 8. So, let's see, instead of having to count up all these individual squares, if we can do it with the formula itself. So here we would have 1, 2, 3, 4, 5. 5 by 1, 2, 3. So here we would have the length times width, so area equals length times width divided by 2. The length we said was 5, the width was 3, divided by 2. Area equals 15 divided by 2. So this triangle's area is 7.5 units squared. Don't let the fact that it's a decimal freak you out. Okay? We'll come back and we'll see if it works in a second. Alright, now let's look at this one. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, I'm going to turn my page so I just have more room to write. Area equals length times width divided by 2. Area equals 5 times 4 divided by 2. Area equals 20 divided by 2, so the area must be 10. 10 what? 10 units squared. Okay, good. So now we have this guy left. Without doing the formula, without even counting the sides, what do you think this area would be? You could brainstorm. You already know what these two pieces are, and you know what the whole thing was when it was together. So is there a possible way without using the area formula to figure out how much that was? Let's see if we came up with what you just discovered. Now here's an interesting triangle, right side up, okay? Obviously we know down here is the base, okay? But what's the height? The height could be here, it could be here. On this triangle, it was all the way over here. Where's the height? Well, in a triangle, the height is always the point where it's running straight down. It makes a 90-degree angle with the bottom. And it just so happened that the 90-degree angle was right here. Okay? But here's where their 90-degree angle is. So the height would be this line running straight through the middle. That's what we're going to call the height. And then this along the bottom, this red part, this red line I'm going to make along, is the base. Okay? So the base would be 1, 2, 3, 4, 5, 6, 7. Base is 7, and the height is 1, 2, 3, 4, 5. 5. Okay? So area equals length times width divided by 2, because remember it's a triangle. So the area would be 7 times 5 divided by 2. Area would be 35 divided by 2. So the area would have to be, who knows the math, 17.5 units squared. This whole thing should be 17.5 units squared. And let's see if that works, okay? For these three triangles, we've gotten that one of them is 17.5 units squared, another one's 10 units squared, and another one is 7.5 units squared. We fill, ooh, sorry, you can't see my writing. Let me zoom in to my math. If we put in our decimals, add them together, carry the 1, we'll get 35 units squared, which was the exact original amount that we started with down here. So our 10 units plus our 17.5 plus our 7.5 together gives you 35 units squared.